be taken one complete block, and the other should be some, it is going to be full half of the half, or some 20% is going to be filled. Okay, 128. What is the remaining? Remaining is something 128. The remaining block size 128 to 30. So the 62 will be there. Okay, it is going to be occupied only some 62 space. It is going to be occupied some 62 MB. The other block is going to be taken some 62 MB. Okay, let us think that you have a some 62 only. This one is some 62. Okay. Okay.
Shouldn't it be 72?
Some 62 it is there. Okay. This block. Okay. Now tell me here, as it is a some 3 node cluster, I can easily find out. Okay, it is in data node 1. By default, Hadoop is going to be maintained. Replication factor is 3. So it is going to be maintained 3 copies. I will tell you how it is going to be copied 3 copies. That is in a rack awareness concept. In the regular classes, I will going to be, I am going to teach you that. Okay. So here, just think that it is going to be stored in different data nodes. Okay, 200 MB file. Now, as it is a simple cluster, I know it is in data node 1, data node 2, data node 3. But take a some 100 node cluster, 100 systems are there. I have a different files. I have some 1000 files are there. How I can identify? I cannot remember. Yes. Are you getting me?
Yes.
So someone should store, or someone should have a all these transaction logs are where it stored. My file 1, your file 1 is stored where it is. See, initially the name node contains all entire data nodes information. Okay, this data node, how many blocks it contains, what are the blocks. Okay, and the data node, how many blocks it contains, and data node 3, how many blocks it contains. It will have the entire information, and again it will also contain, say, okay, information. It's called some, for example, it is a some transaction log. We can call it as a some edit log in the name node. It will store like this the file 1 metadata. You can say the metadata. Metadata is nothing but, libraries. If you take one well established library, so catalog is in the library. Have you reached any time for library?
Yes, I know what a library is.
So what is the catalog in the library?
Catalog in a library is like it's the memory mapping from variable names to the memory addresses.
Yeah, that means it can say, suppose you have some different department books, computer related or mechanical or civil. Okay, different subjects you have it, and again in the different subjects you have a different books. Okay, like if you take some computers, Java, okay, .NET, or else it's the mainframes or Hadoop. You have again different books. So the catalog, it is going to be refer in which room, in which rack, in which cell, okay, which book is kept. Am I correct?
Yes.
So here the name node is also going to maintain. Here you can say your file 1. Okay, the file 1 is your one book, something called. So the name node, it should contain the information like, I am data node 1 is D1. I am referring it as a some D1. So it is in, and each and every block has a some name, 1, 2, 3, 4 or something like that it have. That is an internal architecture, how it is going to be having the naming convention. Okay, file 1, some data node 1, it occupied some block 1 and block 2, and again it is in the another copy is also here, the data node 2, some block 2, okay, comma block 3, and again it will have some information called in data node 3. It have some block 1 comma okay block 2. So here, so when suppose when you want to fetch this file 1, you can easily find out the data s where it is. Now, so for example, now I know where the data is. That means here my name node has communication with my all the data nodes within heartbeat second of time, within our heartbeat. Okay, like that it is going to be how it has to get the information from the data nodes, whether it is died or okay, whether it is live or dead. Entire information, the entire the data node information is going to be passed to the name node. Okay, and it will have entire information of file 1 where it is stored. Okay, suddenly I want to find out suddenly if I want to find out some I want to find out my file 1, I need to retrieve my file 1 data. So it can directly go to the data node 1 and to this blocks, and I will get the data. Okay, forget about the 2 copies. Okay, I will tell you why we are going to maintain 2 copies. It is for disaster recovery management. I am going to keep the we are going to put 3 copies of data. I will tell you the importance of that. First, concentrate on 1 copy. So here, so I can easily find out the data where my data is. Yes, I don't need to search in entire blocks. I can easily search in only in 1 block. Wherever the data is there, I can easily fetch. It will directly go there and find out the block, and it will retrieve the data. Yeah, Ankur, are you getting me, or you are any?
I got you. I understand. Thanks to our
Yeah.
name node, we now know exactly which blocks we have to access in each of the distributed nodes.
Yes. So I can easily get my data. Yes, I can easily, something called I can say, I can easily fetch my data because my name node knows where it is. My name node knows where it is. I send a request to the name node, and I can easily get the data. Okay. So because my name node contains all my this file 1 information, whether it is in data node 1, okay, data node 2, data node 3, everything I easily get it. This is called a Hadoop distributed file system. And again, here I have some name node. I will tell you what is the importance of name node. Okay, secondary name node. I can say it is some secondary name node. Okay, this is called, I'm just giving some secondary node. This is called secondary node because this is passing the information. The name node is passing always the information to the just a minute. Okay, it is passing the information to the secondary name node because name node is the single point of failure in Hadoop cluster. If due to because of any short circuit, is it okay? Okay. So due to because of any short circuit or something happened to the name node, okay, we will lose entire our data. That means if metadata is lost, our entire cluster is going to be down. The heart of in the Hadoop system is the name node. If the name node goes down, everything is going to be down. Our business is going to be stopped. That is why, they are going to keep on sending the log to the secondary name node. If I stored some file 1 in my Hadoop system, okay, automatically it is going to send the same information where it notes this log. Okay, this file 1 D1 Okay, this log is going to be stored into the secondary node. Every time, each and every transaction, it is going to be sent to the secondary name node, and that is going to be kept in some other place, not in where the name node kept. They are going to put in different places. Okay, so that I can easily restore my data, and again I can have another mission, and I can run it, and it is going to be done. I will explain you clearly, just as to understand you what is the Hadoop, to say the differences between this NTFS distributed and Hadoop distributed file system. I am just giving an overview to this. So that means we have a the difference between the distributed and Hadoop distributed file system is the major difference. So if someone says, what is the, someone asks some question like, what is the difference between distributed and Hadoop distributed? Even in distributed also, the data is going to be distributed and it is processing. But you should say something here, it is going to be done. It is it will have some other services called the name node, the secondary name node, these things. Okay, that is what that in such a way we can differ distributed and Hadoop distributed file system.
So the Hadoop distributed system has a secondary node, and that's one. And is that the key difference, or is there one other aspect to it?
No. It is, see, in the distributed file system name node, and even in the distributed file system, the data nodes are not going to be splitted into a blocks. Whereas in the Hadoop distributed file system, the data nodes are going to be splitted into blocks.
Okay.
That is the difference. The distributed file system. It is not a full Hadoop. It is a just Hadoop distributed file system. Hadoop is nothing but HDFS, Hadoop distributed system plus MapReduce. Then we can say it is an Hadoop. It is an Hadoop distributed file system only, not Hadoop. Now I will go with Hadoop system. See in here, if it is we can say consider it is a Hadoop. Okay, it has some two layers. Okay, it has some two layers. One is HDFS, another one is MapReduce. That is called MapReduce. This is an HDFS. We can say this is HDFS. This is where your data is going to be stored. Okay, and whereas you have a MapReduce on top of HDFS, we have a MapReduce. Now, so you got the clear some overview on HDFS, Hadoop distributed file system.
Yes.
Okay, now we are going with MapReduce. What is a MapReduce? See, usually MapReduce is a process engine. Exactly, if we can say it is in a process engine. Processing engine is nothing but it is going to be process the data in a distributed and parallel way. The data is going to be processed by using you can say with the distributed and parallel mechanism. What is the distributed and what is the parallel? Okay, so I will go with some example. Okay, now I have some 10 bags. Okay, each bag is some 100 kgs. I have some 10 bags. This is one bag. Okay, this is another bag. This is another bag. So like that I have some 10 bags. Okay, so each one is, you can say, some 100 kgs. Each one is 100 kgs. So how many kgs it will come totally?
400 kg.
No, you can 1000 kgs. Yes, 10 bags. I
10 bags.
don't.
I apologize. Yeah, 1000 kg.
Obviously, it is some 1000 kgs. Now I have only one person here to pull. I have a only one person here. Okay, I have a only one person to pull all this. Okay, I have a only one person to pull. This is I have a only one person here to pull all the bags. Okay, to pull all the bags. This okay, this and everything is going to pull. So see, obviously it is taking some time to pull all the bags for him. Yes, am I
Yeah.
correct?
Yes.
So in the same case, I have a some 5% or some 7 or 6 or 10%. So how it is going to be done? The work is going to be done in a quick time. Yes.
Yes. We can distribute the 100 kg bags to each of the individuals.
Okay. Now, so how the work is done here? It is a distributed and the parallelly the work is done. Am I correct?
Correct.
The work is done in a parallel way. So obviously it is going to be taking very less time when compared with one man pulling. Okay, I will tell you another example. Now here you can easily count the timing also. Okay, so I have a one circle. I have a one circle. I have a one circle here. Now I have a one. You can say something called some center figure. I have it. Okay, some just I'm taking this one as an example. Okay, I have a some center point. Now here I will go with I have a one flag I have here. I have a one flag here. I have another flag here. I have another flag here. I have another flag. I have another flag. Now I have only one person. I have only one person to collect all my flags. Okay, and now here for each and the distance you can say here the distance here all the ways it is the same. Okay, the distance is same and it will take 5 minutes to pick that flag and again return back to reach the same point here. It will take 5 minutes. 5 so totally how much time it is going to take?
25.
Now if I have a 5%, how much time it is going to be taking?
5.
So obviously here the rate of speed is increased. Yes,
Yes.
this is way by using this mechanism, this architecture, the map reduce is going to be process the data. That means I have my data in blocks. Am I correct? As I said in the HDFS, where my data is going to be stored.
It's going to be stored in blocks of 128 MB size.
So now here 200 MB file is stored in 2 blocks. Am I correct?
Correct.
When it is writing the data, it is writing sequentially. When it is trying to read the data, it is taking randomly. Randomly is nothing but it is going to pick the 2 blocks at a time, and at some point of time it is going to be merge and shuffle and sort, whatever it may be, and we are going to get the output. So it will take very less time as compared to the other traditional technologies.
Yes.
So that is the logic behind in the map reduce. And I will tell you how it is map and reduce, how internally the data is going to be splitting in the map reduce and how it is going to be processed. Okay.
Okay.
So are you clear what I am trying to say, or you are getting any ambiguity or confusions or concerns or something?
No, I think I understand.
Okay. So you can check with your organizer. Where I will let you know the timings that and all uh, to the organizer. So I am done from my side. Any questions or uh,
So
anything from?
I have a quick question. So I'm actually this is a part of the Aduzo program, right? EDUZZA. I'm
No,
kind
I'm
of
not getting.
Oh,
Can
okay.
you
Well,
come
so
again?
I'm kind of new to this whole this lecture system, and I don't actually know any details on how anything works. And I was wondering if you can like inform me. It's like how many lectures there are going to be, and how will I be evaluated to show that I understand the material that you've taught?
The virtual system means you mean to say where you are going to practice Hadoop or
How will I? So if while I'm taking this course to study
okay,
Hadoop, how am I going?
okay.
Like, will there be examinations or anything of the sort, like some sort of test to see if I understand Hadoop, or are they just lectures? How does this work?
No, see, it is just for a training program. Okay,
Okay.
and if you want to write any certification, the Cloudera or Hortonworks, they are going to provide the certification. That may be around in your cost some $250 or something. Okay, that
Okay.
examination cost. That some authorized centers will be there. Okay,
Mhm.
you need to apply there and you need to write the exam there.
Oh, I
Maybe I'll
see.
check with your organizer. Maybe they are
Okay.
going to they have any authorized centers or they can help you. But it is from my side. I'm going to give you the training. How training? That's it. How you can. I'm going to understand the Hadoop and the practicals. How you can do it. How you can do your own. How you can load data, processing data, and do some analysis.
Okay.
In such a way I can help you out.
All right. And as a part of the training, will I be doing like actual programming? Like, will I be actually developing with source code?
It is we have when the course content is like MapReduce. In the MapReduce, we are going to use Java, obviously.
Okay.
So
Uh-huh.
we are going to practice all some 3 or 4 programs. Okay,
Okay.
the
Uh-huh.
MapReduce programs. That means you can say we need to write the code in Java, and we can practice. And the remaining thing, Hive, Pig, everything, it is SQL kind of stuff. And we have a Scoop, okay, and
Mhm.
Woozy also we have. And I will go with the user interface. Actually, people will go with some command line. I used to teach with even user interface because if you get the job, you need to work in through user interface, not through the command line. So I'm just giving you heads up on to the students. Okay, so I don't want my students should be in ambiguity status once they enter into the real projects. So
I
I'm
see.
going to give before itself heads up to them.
Okay. And how many lectures will there be for the training program?
How many classes you mean to say? How many hours?
Yes. How many classes?
Uh, Usually it is a 40 hours, and
Okay.
it depends upon the Saturday and Sunday. And Sunday, if you are going to have the classes and even on Saturday, Sunday, you need
Okay.
to count it as a for 40 hours. At whatever it may be. If it is
Okay.
in weekends or weekdays or whatever, how it goes.
I see. Yeah. So all of my questions were completely logistic. I think I completely understand the whole difference between distributed systems and Hadoop distributed file systems. So I think those are all my questions.
Okay, so you are good.
Yes.
Okay, so we are winding up the session for today. Yeah. Is there anything else to me? The organizers. Yeah, hello. No, even I'm unable to hear anybody. I think Ravi, Sandeep, Sonia, I'm seeing Ravi. So is there any questions or concerns for me? Yeah, yes, Sandeep. Yeah, see, usually people will the practical programs, you can say. So they usually go ahead with any creating tables or uh, all the query languages that they are going to teach through the command line. But in the real time scenario, when if you want to work on some projects, that is not going to be working out. It is only for testing, maybe unit testing, that is going to be working. You need to use some user interface to create all these scripts. Scripts is nothing but some code. You need to write some Hive scripts, put it into some file, and Pig scripts you need to put into some file, and you should have in some directory. Then the paths and everything we need to. If you can do it through command line also, but it will take so much time to do with the command line. If you are going to do with the HUE, okay, that is an user interface. You can easily build your project, and so even if the practice here itself, it will it is very easy to work with the projects. Are you getting me, or I think I'm getting some. Okay.
One more final question. Will there be VODs of this uploaded at some point? Will I be able to review the footage?
No, can you come again?
Will there be a recording of this lecture uploaded somewhere where I can view later?
Well, no, actually, the organizers are doing that. I don't have permissions to. I am the trainer. I
Okay.
don't have, uh, mm, even to record it.
All right. So I have to ask the trainers for. I mean, I'm sorry. I have to ask the organizer for the recorded video. Correct?
Yeah, you need to check with the organizers.
Okay.
Maybe those who are you are going to report.
I see.
Yeah, Sandeep, you have anything for me? No, still time is not confirmed. I need to check with the organizers because I have. I will let you know the timings because. Okay. I will let you know the timings to the trainer, the organizer. Okay. Okay. Again, is there anything for me? Hello.
No, those were my final questions. I'm done.
Okay. I'm going to wind up this session. Have some other work. Okay.
Okay.
Bye. Bye.
Bye. Have a nice day.
Yeah. See you the shape.